So previously we talked about how if we had a line that started at the origin, and we're going to just use what we have, the scale we have here, which is just fine, that if we went up 60 and over 6, we could plug that into a calculator and we could compare the rates of the change on all of them. So 60 divided by 6 means the rate of change would have been 10 over 1. And every point we did this, we would find the exact same thing. Well, look at this table and let's see what happens with this table. This table is just a little bit different. If up 3 over 50, up 4 over 60, well, my changes here, let's just look at them. My changes here are 1. My changes here are 10. So 3 plus 1 is 4, 4 plus 1 is 5, 50 plus 10 is 60, and 60 plus 10 is 70. So I still have a change of 1 over 10. So wouldn't this line be exactly the same thing? Well, let's bring back our calculator and just see what happens in this case. So we're going to go ahead and use division. So 50 divided by 3. Whoa. 16.667. Let's try the 4. Oops, let's try 60 divided by 15. There's something a little bit different here. Let's try the last one. 70 divided by 5. And it's back to 14. So the rates of change look different. But they're not different. We knew that this was a change of 10 over 1. Look, this is a change of 10 over 1. So they should be the same. These rates of change are 10 over 1 because y is always over x, so 10 over 1. So the rates of change have changed something drastically. So let's go ahead and plot the points and see what happens. If we go 3, we go up 50. We go 4, we go up 60. We go 5, we go up 70. So what's happened here? Well, let's draw a ray. Let's continue. Let's draw a line. Find out. Oh, it wouldn't work if it goes through 0. There's something a little bit strange here. So let's go. Let's undo it and let's try another place. Let's try another ray. Let's try it. Well, that's kind of weird. I don't know where that thing came from. So let's try it from here. See if we can make the same thing. Whoa. All my points disappeared. It's kind of going slow. I don't know what's happening. Let me delete some of this stuff here. I'm going to delete this line because I don't want that line. I'm going to delete this line, this point. I'm going to delete this point because I don't necessarily want that, but I had one more point. So 3 at 50, 4 at 60, give me 5 at 70. They're a straight line if we look at them. Well, instead of starting down here, let's start up at the top. Let's just go ahead and we're going to just use the line segment. We're going to go through all of these. That goes through there, goes through there, goes through there, goes through there, goes through there. Wow. So what's changed? As you can see, I have a new starting point. And in this case, the new starting point, this one was 0. This one was adding 20. So let's see how that would work. So let's go back to the table, and I'm going to write some stuff up above the table and see what happens. So let's subtract 1. That would give me 20, or 2. Let's subtract 10 from that. That would give me 40. Let's subtract 1 more. That's going to give me 1, and that's going to give me 20. Let's subtract 1 and find out what is actually the y-intercept. Oops, sorry. Back up. Subtract 10 is 30. So subtract 1 and then subtract 10 more gives me 20. So we can see by the table, even though the rate of change is the same, 10 over 1, as this line, there's a different starting point. And that's what this entire lesson is about.